Okay, so we're going to talk about scientific notation. So the motivation for scientific notation is sometimes there are really, really large or really, really small numbers that are pretty cumbersome to write. And so we'd like to have kind of a briefer way of writing them. So, for example, this is how many feet there are to the sun. Which you can see that we have more than 1,000, more than 1,000,000, more than 1,000,000,000. It's a very large number and a lot of zeros to keep track of. And then suppose we're in biology and we're measuring the width of a membrane. Maybe this is how thick something is. And so this would be a very small number, this would be a very large number, and there's a lot of zeros there, right? So we want to figure out if we can kind of condense how we're writing these numbers. So we're going to kind of use the fact that we're in a base 10 number system. And we kind of discussed already that being in a base 10 number system is cool because it means that when we multiply by 10 or divide by 10, we basically shift our decimal point around. So, for instance, I can write 850 as 85 times 10. And I can write 85 times 10 as 8.5 times 10 times 10, which is 8.5 times 10 to the 2. And this is actually going to be our scientific notation. So we have the digits that are in our number, and then we basically have the power of 10 that our number is. So 850 is 8.5 hundreds, which is 10 squared. So another example, we have this very large number, 491 followed by 9 zeros. And I can write this as 4.91 times 10 to the 11. And I want you to notice that the 11 comes from counting how many times I move my decimal point. So if you count how many times right here, we move our decimal point, that would be 11 to get it to where there's only one digit in front of it. And that's actually one of the things you need to know about scientific notation is that we only have one digit before the decimal point, and then the rest of our digits go behind. And then we'll have times 10 to some power. Okay, so here are some examples. So for this first one, we have 580,000. And right now, our decimal point is here. But I want to get the decimal point to where there's only one digit in front of it. So I want 5.8. Well, to get my decimal point from here to here, I'm going to scooch it over 1, 2, 3, 4, 5 places. So I can write this as 5.8 times 10 to the 5. With this other one, I have 620 million, and I want my decimal point to only have one digit in front of it. So I want it right between the 6 and 2. Well, that means I need to move this decimal point over 1, 2, 3, 4, 5, 6, 7, 8. So, in scientific notation, this number is 6.2 times 10 to the 8. And I want you to notice a trend that when we have a number in scientific notation, and this exponent of 10 is a positive number, that means whatever this decimal is out in front, we're multiplying it by 10, and then 10, and then 10, again and again. And so we're making the number much larger. So 10 to a positive integer is going to give us a large number. All right, what about if we have something like 0.00000001? So I want you to keep in mind that the way that we moved the decimal point to the left was by basically dividing out by 10. So this, we're basically going to multiply out by 10. So notice that 0.00000001 is the same as 0.000001 divided by 10, right? And I can keep doing that, dividing out by 10, 0.000001 divided by 10 squared. So I shifted the decimal point again. I can shift the decimal point 5 more times and get 1 divided by 10 to the 7. Well, we know that 1 over 10 to the 7 is just 10 to the negative 7. So I can write this as 1.0 times 10 to the negative 7. So to deal with really, really small numbers, we're going to have 10 to a negative exponent, and that's really because we're dividing out by tens. Alright, so I would suggest pause the video, try to see if you can write these out. Alright, so this first one, we want to get this decimal point to where there's only one digit in front of the decimal point. So I want to write 6.82 times 10 to something. To figure out the something, I figure out how many times I need to move the decimal point. So I need to divide by 1 10, 2 tens, 3 tens. So I divide by a 10 cubed, which is the same as multiplying by 10 to the negative 3. For this next one, we will have 9.5 times 10 to the, and I count, 1, 2, 3, 4, 5. I need to divide by 5 tens to move this decimal point over 5 times. So I'm multiplying by 10 to the negative 5. And notice that the trend is when we have 10 to a negative number, this is going to give us a really small number. All right, so here's some more examples. I want you to go ahead and pause the video and try a couple of these. And then I will write the solutions when you resume the video. Okay, so if we want to convert the first few to scientific notation, we're going to be doing what we were doing in the previous slides. So this one's going to be 2.8 times 10 to the, I'd have to move this decimal point over 1, 2, 3. So I am going to multiply by 10 to the 3. This one would be 1.49 times 10 to the, I move the decimal point over 1, 2, 3, 4. So it would be 10 to the negative 4. Notice I have negative 4 and my number is very small. When I had 10 to the 3, my number was very large. Okay, so now this one we would have 3.6. I have this 1 over here, so I need to keep these digits. I would have to move my decimal point over 1, 2, 3, 4, 5, 6, 7, 8 times. So I multiply by 10 to the positive 8 because I have a very large number here. Now for this last one, the only digit that's non-zero is an 8, so I can write 8.0 just to really specify where my decimal point is. And I do times 10 to the 1, 2, 3, 4, 5. Whoops. So I have times 10 to the negative 5. Okay? Now, suppose we want to convert to standard notation. Well, this, we just use what we already know about converting to scientific notation and kind of reverse engineer it. So I have 3.8 times 10 to the 5th. Well, if I take 3.8 times 10, I would get 38. If I multiply by another 10, I get 380. If If I multiply by another 10, I get 3,800, and so on and so forth. So I know that when I multiply by 10 to the 5th, I'm going to move my decimal point over 5 times. So I would end up getting 38,000. Actually, I lied. You'd have one more. So we can, let me mark this out. So we were starting with 3.8, move it over 1, 2, 3, 4, 5. Gives me 380,000. Okay, now we have 2.71 times 10 to the negative 4th. Every time that I divide by a 10, I'm moving the decimal point over to the left. So I've got this 271. My decimal point is originally here, but when I multiply by the 10 to the negative 4th, I'm going to move it over 1, 2, 3, 4. So that tells me my decimal point is now here, and I have 3 zeros in front of my 2. And now for the last one, 8.9 times 10 to the negative 2. I originally had my digits 8 and 9. My decimal point was here, and I'm going to move it to the left 2 spaces because of the 10 to the negative 2. So now my decimal point's here, and I fill in with a 0.